Yes, we can see it.
Okay, okay. We are still working on with the first category, which is auto takeoff and EOQ. To use it, like I said yesterday, you double click on the main category and it opens to give you access to the other items in it. And we are working on with this third sub item in the main category, which is building takeoff and BOQ. This building takeoff and BOQ has trench details in it. It has column bases in it. It has beams. It has roof, and it has a lot of things in it and block wall. So although we also have some of these elements which I just mentioned under some items here, like as you can see, we have column bases here. We have concrete column. We have concrete fascia and others. Most of what you have here, they are treated within this building takeoff and BOQ. So we'll be working with this for complete project. You only use these other items when you are interested in just a particular element in the project. If you are interested in only column basis, for example, you click on column basis and you use this form that you have here, which you provide the column base, the description, maybe BT1, BT2, and you provide all the details and you click add to give you your result. But in this case, we are working on not just only column basis, but some other items in the substructure. So we are going to use this building takeoff element. So we click on that. When you click it and it shows a blue cursor that is rotated, that means it's still opening. That's a processing symbol. So when this is open, we are going to work on more than one page in this case. But before we proceed, let me open the project that we want to work with, which is the project that has a column basis. It is part of the drawings that I shared or I sent to your emails. So this is the drawing we'll be working with. In using the software, you need this number of drawings. You need the foundation plan, which gives you the arrangement of the column bases and the trenches. You also need the column details, which shows you how the column is arranged and the size of the reinforcement in the column, the size of the columns in the project. You also need column base details that gives you the different types of column bases we have and their sizes. Then you need specifications. As we have here, this shows us the uh, specification that should be used. For example, we are going to need all these concrete cover for the different places in work, like concrete cover in column base, concrete cover in column starter, in columns, in beam slab, and others. Having known this, the next we look at is the first step in using the application, which is the extraction of data. The extraction of data here is similar to what we did yesterday. We are going to need group A and group B data. Like I said yesterday, group A data are data that you need to measure from the drawing. Group B are data that you read directly from the drawing. In this case, we are going to need data like we have yesterday. Let me open the data page that we need. And I'll also show you how we arrived at this data today. So just like yesterday, we need group A and group B data. For this project, the group A data we need the site area, which is 522.7 square meter, the ground floor area, which is 254.6 square meter, the ground floor perimeter, which is 67.5 meters, the trench guard, which is 101.2 meters, and the foundation wall guard, which is 175.8 meters. Before I move to the group B data, I'll show you how we arrived at this data. Like I said yesterday, you can use another application to measure this data directly from the drawing, or you can do that manually if you don't have such application. For example, for the foundation wall guards, you take note that the foundation wall guard is more than the trench guard. I said yesterday that projects that has column bases, you mostly have difference in the guard in foundation wall guard and trench guard. There's always a difference, but project that does not have column bases, they have little or no difference in the foundation and trench guard. So I will go back to the drawing and show you how we arrive at this difference. So I'm going to share another screen now. So on this screen, this is a plan sweep. We use it for measurements to measure out those data, group A data that I mentioned earlier on. And if you take note, there we have on these green lines on the drawing. The green lines are the trenches. Trenches are between column bases, while the block wall is this red line. As you can see, the block wall spans even into the column bases, while the trenches are just between the column bases. That's why the block wall guard is more than the trench guard, because you have block wall even where you have column bases, but you have trench just between the column bases. Where you have column bases, there is no trench. The reason why we are separating the guards is so that the software will just take the trench guards that you are provided and multiply by the trench width and multiply by the depth of trench excavation. Because with this software, you don't need to be doing the docked column basis when you are using it. So if you have this, this is just to show you how to extract the data. when you are measuring for block wall gaps, you take all the gaps, the block wall as shown on the plan. Then for trench gaps, you just measure between the column bases. As we have here, the green lines indicate the trenches. So you can do this manually, just get all the length and sum them up, and you have total trench gaps. So we have our trench gaps. So the stage one is to extract the data which we have here. We have the group A and the group B data. The group B data are similar to what we did yesterday. Then part of our group B data is column-based details. In using the software, you don't need to be doing multiplication to get excavation for column bases and blinding in column base, reinforcement in column base, and even the columns. Once you input all this data, it will generate the result and BOQ for you. So part of what you will do is to write out the sizes of the column bases, that's their dimension and their numbers. We have BT1, which is 1.2 by 1.2, 36 numbers, BT2, 2.0 by 1.2, 2 numbers, BT3, 2.25 by 1.2, which is also 2 numbers. And we have that details from the column-based details, which I'm going to share and show you the screen. Now, you have that in your emails. So this is the page that shows the column bases, their arrangement. So this is BT1, which is 1.2 by 1.2, 36 numbers. And this is BT2, which is 2 meters by 1.2, 2 numbers. And this is BT3, which is 2.25 by 1.2, also 2 numbers. You also need to take note of the trench foundation trench details here, or the section, which okay, this is for the excavation depth for pits. In most cases, the excavation depth for pit and trench are not the same, so you take note of that also. And another thing to take note is the reinforcement arrangement. In BT1, as we have here, the reinforcement is bottom only, while in BT2, the reinforcement is top and bottom. That's a double reinforcement. And also in BT3, the reinforcement is top and bottom. So we are going to take note of all this, and there is a place in the software where we use all that. So now we are done with extraction of the data. Then we'll start stage 2, which is to input the data in the software. So let me share the second screen. So the first page is the site and trench detailed page. Unlike yesterday, we worked on only this page. Today, we are working on more than 1 pages. We work on 3 pages. The first is this site and trench detailed page. Then after we are done with this page, we click the next tab. It will take us to column-based details. That's where we input the column-based details. Then The next tab we work with or work on is the ground beam, but we don't have ground beam in this project, so we leave out this one and go to the next, which is the regular column details in substructure. Then we'll check the drawing. We don't have a round column. If we have round column, we would have also worked on that. So I'm going to open the other page beside this. So we start with entering the details for site and trench. Then after that, we move to the column base. So the first on this page is a description. Put the description, which is a substructure. Then the next is the site area. And the site area, like I showed you earlier on, is 522.7 square meters. Then the next is the ground floor slab perimeter, which is 67.5 meters. Then the next is the ground floor area. The ground floor area is measured as 254.6 meters. Then the next is the topsoil excavation depth, which is 0.15 meters. Then the next is oversight slab thickness, that's 0.15 meters also. Then the next is the laterite filling and rock filling thickness. Just like we have yesterday, we are using 0.3 meters for laterite filling and 0.15 for rock filling. Then the next is the trench gap. The trench gap is part of the group A data, and I showed you earlier on that the trench gap is 101.2 meters. Then the next is the foundation wall gap. Foundation wall gap is 175.8 meters. So you type that as well. Then the next is the foundation wall thickness, which is 0.23 meters. Then we have the foundation wall height. The foundation wall height, we are going to compute this from the section, the foundation and section. So let me share the screen again and show you how we arrive at that. This drawing we have here is for the excavation for the column base details. Like I said earlier on, the trench excavation is different from the pit excavation. So we are using this as the details for the trench excavation. So here we have the trench the trench excavation depth here is 0.75 meters. The foundation wall height here is 0.52 meters. So we are still going to use these details. So when we get to column basis, we are going to use those other details. So we are going to use the foundation wall height to be 0.52 meters. Then the next is the trench width. The trench width is 0.69 meters. Then trench excavation depth is 0.75 meters. Then the blinding. In this case, we don't have blinding in trenches, but we have blinding in column basis. So you put 0 here. When we are working on column basis, we provide the blinding for column basis. The next is trench footing thickness, which is 0.23 meters. Then the next is this for bulk excavation. What we have here is pad and strip foundation. So we put 0 in this bulk excavation area, and bulk excavation gaps to put 0 there because we are not doing bulk excavation. So the next is substructure plaster height, which is 0. We have this here. Substructure plaster height is 0.3 meters. The next is number of work, which is number of projects, and we have just one project here. So immediately you click this and you click the forward navigation bar or the right navigation bar on your keyboard. It will generate all the results that are associated to foundation trench. Here we have the results or quantities for site clearance, topsoil excavation, trench excavation, disposal for topsoil, disposal of surplus material, leveling and compacting for trench, earthwork support for trench, anti-termite for trench, backfilling, laterite filling, rock filling, blinding is 0, oversight slab concrete volume, trench footing volume, slab to the edges of formwork to the edges of ground floor slab, mesh reinforcement, trench block wall, damp-proof membrane, damp-proof course, plastering and painting for substructure. So we are done with this page. Like I said,
sorry, Stanley. Can you please enlarge the screen? It's only on one side, and they are complaining that they are not seeing all the better. Thank you.
Okay. Let me quickly go through it again because of the screen size adjustment. Like we did yesterday, this menu bar, the menu part of the screen is adjustable. If you hover your cursor to this demarcating line, it will show you you see if you hover your cursor there, the sign will change. When the sign changes, you click and drag. So with this, you can reduce or increase the width of the work section. So we started by extraction of data from the drawing. Then after we've done that, we start imputing the data. The first is the site area, which we imputed. The next, the ground floor slab perimeter, which we imputed. The next, the ground floor area, we imputed. Topsoil depth, oversight slab thickness, laterite filling, rock filling, the trench gaps, which is this, foundation wall gaps, which is this, foundation wall thickness, which is this, foundation wall height, which is this, trench width, trench excavation depth, trench blinding thickness is 0, trench footing thickness, bulk excavation area, which I said is optional. You only need it for bulk excavation, but projects that are not that does not require bulk excavation, like what we have now is strip and pad foundation. You put 0 in this bulk excavation area, and also the bulk excavation guide, you put 0 there. Then the next is the substructure plaster height. You put the value there. Then the next is number of work or number of projects, which is 1. Then immediately we did that, we have results generated. Result for site clearance area, topsoil excavation area, trench excavation volume, disposal of topsoil volume, disposal of surplus material volume, leveling and compacting area, earthwork support area, anti-termite area, backfilling in cubic meters, laterite filling in cubic meters, rock filling in cubic meters, as rock hardcore filling. Then the next is oversight concrete volume, trench footing volume, formwork to edges of ground floor slab, mesh reinforcement, trench block wall area, damp-proof membrane, damp-proof cuts, plastering and painting to the external walls in the substructure. The next we do is to save this page. Before we save the page, we need to create a folder inside that main folder that we created yesterday. We create a folder for this particular project. I showed you how to do that yesterday, but I'll go over it again. To create a folder, let me share the screen. You go to your desktop or your home screen first. Now, on the home screen, we have this folder which I created yesterday. The folder is called the EQS2 project. So if you don't have it, you create a folder. This is the folder that will be saving other projects that I'll be working on. It's a main folder. So inside it, we created a subfolder in it for the project we worked on yesterday, which is a community library. So now we are working on another project, which is a duplex project. So you right click to create a new folder and you give it a name. So let's just give it the 2 project. So after you have created this folder now, then you can go back to the software and you save each of the page you are working on inside this day 2 folder, or whichever name you like to give it. So now back to this page, to save this page that we just worked on. Remember, we have only worked on one page, which is the site and trench details page. And if you read the document I sent you, that the page has each page has input and output section. The input section is where we inputted all the data. Then the output section is the parts that have 000. That's the output section. So once you've done that, you are done with the input section. So this is the last column in the input section. Then the next is to save the page by clicking the save button. So when you click the save button, a pop-up window will appear. So like I said yesterday, whenever you click the save button, it usually opens the last folder that you worked on. And I said you should check the file path, which is at the top here. This is called file path. This file path is showing that you are currently on community library folder. So to go back to the to choose the appropriate folder to save this project, and you click desktop. So you navigate to the folder you are supposed to save the page in. When you click desktop, it brings out all the folders on your desktop. So this is the folder we are working on, which is the EQS2 project. You double click that folder. When you double click it, it shows you the two folders we have. In case you have more than two folders, all the folders, the subfolders inside this main folder, EQS2 project will appear. So day 2 is the folder we want to save our work into. So you double click day 2. You see the file path has changed now. Now we have EQS2 project and day 2. So whatever we are saving, I save it into this folder, day 2 project. And I said you must save each page with the title of that page. The title of this page is site and trench details. So you save it with the same site and trench details. Purpose of doing this is for easy identification when you want to make reference to the data. So when you click save, it saves. In some cases, you see this cursor turning. That means it's still processing. So after it has finished saving, we move to the next tab, which is column-based details. In the column-based details, we are only going to provide the column-based type. In this project, we have 3 column bases. We have BT1, BT2, BT3. And the software allows you to input data for, even in cases where you have more than 100 different types of column bases, you can input the data for all the column bases. You can have BT1, BT2, BT3, up to BT100. And the software will calculate all the quantities that is associated to column bases in terms of excavation, leveling and compacting column bases, anti-termite treatment, earthwork support, concrete works in column bases like the blinding, column based footing, and the reinforcement in column bases, and even the formwork to the sites of column bases. Everything will be calculated for all the column bases. It will sum them up and it will send to the bill of quantities that will be generated at the end. It's still saving. Why it's saving? Let's look at the column-based details here. We have BT1, which is 1.2 by 1.2. We have BT2, which is 2.0 by 1.2, and the number is two numbers. Then we have BT3, which is 2.25 by 1.2. The number is also two numbers. And this is the drawing that shows, say, BT1, BT2, and base type 3. I also said we should take note of the reinforcement arrangement. For base type 1, the reinforcement is Y20, and it is top and bottom. As you can see, the reinforcement for base type 1 is Y12, it's Y12 at 200 center to center, and it is, if you check, this is where you determine whether it's bottom only or top and bottom. Here, base type 1 is bottom only. Then for base type 2, it is also Y12, and it is 2 meters by 1.2 meters. But this is top and bottom. And base type 3 is also Y12. That's the bar diameter, and it is 2.25 by 1.2, and the reinforcement arrangement is top and bottom. So once we have determined all this data, this is part of the data extraction that I told you, the step 1. We move to sorry, it's still processing. So, but if your own has finished processing, you can click on the next tab, which is column-based details. Okay, before as it's still loading, let's look at the next tab we'll work on after we work on column-based tabs. We're also going to work on the columns in Substructure. And in this project, we only have regular columns. The software allows you to provide details for round column and regular columns. So the columns here are 225 by 225. In some projects they use 230, but you know it's still the same thing. When you approximate, it's 230. If you check the foundation layout, even from the foundation layout, you can see that all the columns in Substructure, they are all 230 by 230 or 225 by 225. So after this has finished saving, the next you click is column-based details. So when you click column-based details, the page will load. So this is the column-based details page. So in this page, the first thing is you provide a description for the base type. This is where you provide base type 1. You can write it in full or you can approximate. So let me use base type 1. Then after you have typed the base type 1 in row 1, you can decide to start with base type 2 if you wish. You can put base type 1 on row 1, then the next row is for base type 2. But before we do that, let's check the reinforcement arrangement. You see the bar arrangement here is showing bottom only. And if we cross-check our column base type 1, the bar arrangement is truly bottom only. So we are okay with that. The next is you provide the column base length. There are some abbreviation here. Here you see COL, it means column. As a quantity surveyor, I believe you are familiar with most of the terms that we used here. COL means column. So column base length for BT1 is 1.2 by 1.2, and the number is 36 numbers. So we put that. The length is 1.2. You use your right navigation to go to the next cell, and you provide the column base breadth, which is also 1.2. You use your navigation to go to the next. Then the next is the column base numbers. For that PT1 is 36 numbers. So you navigate to the other cells. The next is the column base bar diameter. This means column base reinforcement diameter. You see, even the diameter is abbreviated. I believe as a QS you should understand most of the abbreviations and terminologies used here. From the column base details, the column base reinforcement in base type 1 is 12. And you take note of the unit of measurement that is written with each of the column headers or title, each of the cell titles. Here you see this is in millimeters. Why this is in number? That's why we inputted data there in number. If you check column base length, the unit is in meters. If a unit is in meter, even if your value in the drawing is in millimeter, you must convert it to meter so that it will match what the software is requesting, so that you not have error in your data or in your results. So we have here the column base bar diameter is in millimeters and the diameter is 12. The next is the column base bar spacing. From the drawing is 0.2 meters. You take note that in the drawing it's given in millimeters, but in the software it's requested to be provided in meters. That's why we have to convert it from millimeters back to meters to match what the software is requesting. So the next is the column base bar bend. What is this? This column base bar bend means the bend in the reinforcement in the column base. Let me show you. This is the bar bend they are talking about here. This is the bar bend. So for this project, we use 0.15 as the bar bend. It depends. Some use 0.1, 0.15, 0.2. Then the next is the column pit excavation depth. Column pit excavation depth is also in the details here. What we have here is 1.45. For this 1.45 includes it's up to the ground floor slab. So we deduct 150 from this, we have 1.3 as the column base or column pit excavation depth, 1.3. Then the next is the blinding. The blinding should also be given here. As you can see, we have the blinding is given as 50. So as QS, you know this is 50 mm. So you go back, you will not type 50 mm here. You check the unit of measurement on this cell, which is in meters. So you need to convert 50 mm to meters, that's 0.05. Then the next is the column base thickness. One of the goodness of this software is even if each of the column bases has different thickness, you can provide the thickness for BT1, BT2, BT3 in their individual rows. So we check for BT1, the thickness is this 400 mm. Remember, we are working with meters here, so you convert to meters as 0.4 meters. The next is the column base concrete cover. Like I said earlier on, there are lots of abbreviations here, so you should be careful. Here is a column base concrete. There's concrete is shortened to the CONC dot. That means concrete. And the column base concrete cover is gotten from the specification page. So these are concrete cover. For column basis is 50 mm, column starter 50 mm, in columns 40 mm. So we work with what we have in the specification. So we use 50 mm as the column base concrete cover. So we use 0.05 there because it is in meters here. You see, we already have the result generated. The reason why we have a result here is because we have specified the numbers. So if I should go back now and I change the number to 0, you know, we have a number of column bases here, 36. Immediately you have typed the number, the software is calculating the result. So here we have a result generated for column pit excavation volume, leveling and compacting, earthwork support, anti-termite, blinding, column base concrete volume, column pit backfilling, disposal, formwork to edges of or sides of column bases. Then it gives you the reinforcement in column base. It gives you reinforcement in meters, in kg, and in tons. So you have options. But the one that will be sent to the BOQ is this second option, the reinforcement in kg. That's what the software will transfer to the bill of quantities. So with this, you see, we are done with all the taking up for column base, base type 1. So we move to the next, which is base type 2. And you just type it just right below base type 1. So we start with description, base type 2. As you can see, the next column here is the bar arrangement. Bar arrangement means reinforcement arrangement. The reinforcement arrangement needs to be specified. Before you do that, let's go back and check what we have as the reinforcement arrangement for base type 2. Back to the drawing, this is base type 2, and the reinforcement arrangement for base type 2 and base type 3 are top and bottom. So take note, this is how you specify the bar arrangement for this particular row, which is base type 1. It's not compulsory that you arrange it as it comes. You can start with base type 2 if you wish. You can also start in this format. So but when you are working, you take note of the reinforcement arrangement. So to specify base type 1 reinforcement arrangement, you go to the top of this page. Here you see this drop down. This is called drop down. Drop down is a box or a tool that gives you a list of options to select from. So here, the title of this drop down is column-based bar arrangement. So when you click this column-based bar arrangement, it gives you two options. The two options is bottom only and top and bottom. So before you select an option, you need to change the row to row 2 because we are working on row 2. Row 1 is for base type 1. Row 2 is for base type 2. So before you make any change here, you need to change the row to suit what you are working on. You see, when I change this to 2, we now have a bottom only here. So, but we are not using bottom only because in the drawing, base type 2 is top and bottom. So you change this to top and bottom. So we now have the base type the bar arrangement for base type 2 is top and bottom. Then the next is you start providing the dimension and other details of column base type 2. From the drawing, the base type 2 is 2.0 by 1.2 meters. So the length is 2.0. The breadth is column base breadth, which is the next, is 1.2. Then the number, that's number of base type 2. Remember, we are working on this second row, which represents base type 2. So you provide the details there, which is 2. Then the next is the bar arrangement, the bar diameter for base type 2 is also 12. The spacing for base type 2 column base bar spacing is also 0.2. The bend for the reinforcement in column base type 2 is also 0.15. The excavation for base type 2 is 1.3. This software also allows you to have different column base depths. If the site is not level, for example, if it has varying heights, in some cases the excavation depth for column bases may not be the same. So with this software, you can even specify the excavation depth for each of the column base types. So the next is the blinding. The blinding for base type 2 is also 0.05, which is 50 mm. Remember, we are working with the unit of measurement, which is specified here. The next is the column base concrete thickness. So even if base type 1 has a different thickness from base type 2, you can provide that here. But in this project, they all have the same base thickness, which is 400, 400, and 400. So we use 0.4 here as well. The next is the column base complete cover, which is also 0.05. So from here we have the result for base type 2. So the software will sum up excavation for BT1 and BT2. It send it to the bill. Same, it will sum up for all these other columns that we have. To sum up the leveling and compacting for all the column bases, and it just add it with what we have in the trench, you now have a general leveling and compacting. Same for the earthwork and others. So before we go through that, let's quickly work on the third column base type, which is base type 3. Provide the description base type 3. The next is to specify the column base bar arrangement for base type 3. So we change this row to 3. So when you change it to 3, the reason of changing it to 3 is because we are currently working on row 3. And row 3 represents base type 3. So you click this and for example, if base type 3 is bottom only, you change this to bottom only. But what we currently have base type 3 is top and bottom, so you need to change this to top and bottom. So the next is to input the data. Base type 3 is 2.25 by 1.2 meters, and it is two numbers. So we say 2.25, that's the length, the breadth is also 1.2. The number is 2. Then it has the same details in terms of reinforcement, sizes, and others. So I'm just going to use the same details. The bend is 0.15. The excavation depth is also 1.3. If it has different, if the project you are working on has, if the column base has different details, you need to provide the details as specified in the drawing. The thickness is 0.4 for the column base concrete. Then the concrete cover is 0.05. So I will show you the effect of the reinforcement arrangement. You see, the reinforcement we have in meters, kg, in tons. Yeah. If I should change this now to bottom only, you see that it has changed, it has reduced. What we have here is for bottom only is this value. Then for top and bottom, the software multiplies this value by 2. So when I change this top and bottom, you see we have a different value. And I can also do the same for the row 2. Remember, row 2 is representing base type 2. If I change this now, and I should change this row 2, you see row 2 value has also changed. So if I change this, so you see, it's effective. So with this now, we are done with our taking off for column bases for this project. Now we have the total excavation. The software will sum this for us and send to the bill as total pit excavation. It will sum this for leveling and compacting and send to the bill. It will sum for earthwork support, sum for anti-termite and for blinding. So in the bill now, you have summation of this as your total volume for blinding. For concrete in column base, it will sum this and send to the bill. Same for backfilling. And for the reinforcement, it will sum this kg, the total kg, and send to the bill. The next is to save this page. This is the second page that we've worked on. So we click save page to save it. And I said earlier on that whenever you click the button, it takes you to the last folder that you saved a file into. And since I say you should check the file path, if the file path is the same as what you want to work on, you just go ahead and type in the file name. So when I check the file path now at the top here, the file path is still showing the 2 projects, which is the correct folder I'm supposed to save this page into. So now I type in the file, the page name. Remember I said you must save each of the page with the name of that page. The page name of this, the page title of this page is column based details. So the file name here is going to be column based details. So after you've done that, you click save. So when you click save, you go to the next tab. The next tab is ground beam. details. We don't have ground beam in this project, so you don't need to click it. You just go ahead and click the third tab, which is regular column details in Substructure. So when finish saving, I'm going to click that tab. But before it finished saving, let's look at the data that we need to extract from the drawing as regard the column in foundation details. In column in foundation, the software is going to ask for the column sizes. You can have 230 by 230 columns, 450 by 230 columns, 600 by 230 columns, any column sizes. So when you provide so these are the column sizes that we have. From here, you can see this is 225 by 225. This is also 225 by 225. So since this is 42 numbers, column 1, column 2 is 2 numbers. So since they are the same type, we just sum this 42 plus 2, that is 44. So our column is going to be 44 numbers, and the dimension is 225 by 225, but we can approximate to be 0.23 by 0.23. So here we are going to need some data, like we are going to need we are going to do this data extraction together here so that you understand some details that the software is going to request. So this is column, we call this regular column details. Then we append it as sub. So this means substructure. So first we need the description, column 1, which is 0.23 by 0.23. Although it's 225, but I'm using 0.23. You can use 0.225 if you wish. The number is 42 for column 1. Column 2 is 2 numbers. Then the next is the height. So let's say the next is a column in foundation height. So I'm going to abbreviate here. This is COL is for column. Then foundation, I'm just going to use FDN is for foundation. Column in foundation height, it's we take the value we have here is 1.45. This value is from the bottom of the excavation to the top of the ground floor slab. So the column stops just right below the ground floor slab. Meanwhile, the reinforcement of the column, that is the starter bar, it extends up beyond the ground floor slab, and we now have the projection, which you usually see. If you check here, you can see the projection, which I was talking about. So we are going to have 2 heights in this case. The first height is the column in foundation height. The second height is the starter bar length or starter bar height. So let's say starter bar length. So first is the column in foundation height. Column in foundation is the height from top of the column base to bottom of the ground floor slab. And from the details we have here, The height we have is, if we deduct 150 from this 1.45, we have 1.3. So here we have 1.45 minus this ground floor slab, which is 1.15, 0.15. So the excavation depth now is 1.3. So, but we are interested in this height from here to this point. That is what we want to get. So this portion that I mark now is what we refer to as the column in foundation height. It's very important to understand the meaning of these terms that we use, because if you input the wrong data in the wrong cell, you are going to get wrong results in the final BOQ. Then the next one here, the starter bar length. Starter bar length is from inside the column base here. Okay, let me use another color. The starter bar is from here, inside the column base, into the column, into the ground floor slab, then projection. So you know that this starter bar length is going to be longer than the column in foundation height. So in this case now, the column in foundation height is what we are computing now, which is the one in red. Remember, the excavation from here to here is 1.3 meters because we have deducted the slab from this. That's why we have 1.45 minus 0.15. So we have 1.45. 1.45 includes the base here, the footing. And the footing in this case is not 0.23, it's supposed to be 0.4 because the footing, the column base footing here is 0.4. So this is supposed to be 0.4. So you say minus 0.4. So this is 0.9. So 0.9 is the height from the height of column in foundation height. The reason why we need this column in foundation height because that is what the software we use in calculating the concrete in foundation. Sorry, the concrete in column in foundation. And it will also use that same height to calculate formwork to site of column in foundation. Then why we need the second, this purple line, which is the starter bar length, the software uses that length to calculate the total quantity of reinforcement in foundation. That's the starter bar. So for this column in foundation height is 0.9. So we put 0.9 meters here. The first is 42 numbers. So the next is starter bar length. So to calculate starter bar length now, we are going to use this 1.45 direct. Then we say this 1.45, then plus this bend in the foundation, sorry, bend in the column base. We can use 0.2 here. Then the next is the projection. The projection is not specified here, but we can use 0.7. So total computation now is 2.35. This is the length of the starter bar. Remember, this 2.35 is this bend we have here plus the 1.45, which is the total depth of the excavation for pits and the projection. That's how we got 2.35. So now we also need to check the size of the starter bar. From here, you see it giving us 4y16, and the stirrup, this is the stirrup. Stirrup is y10 at 200 center to center. So we're also going to take note of that. So you say reinforcement is equals to y12. Reinforcement diameter is equals to y16. Remember, we are working on column in foundation details. So what we have here is y16, and the number is 4. So you say 4y16. Then the stirrup is y10 at 200 center to center. So with this now, we are going to input this data in the software. Okay, before we do that, I'm going to click on the page that we are going to enter the column in foundation details. We are going to leave out this ground beam. We don't have ground beam in this case. We are going to work on another project that has ground beams. So the next is this regular column details in Substructure. So when I click that page, when the page opens, we are going to enter all this data in it. When we enter this data, the software is going to give us the concrete in the columns, the reinforcement in the columns, the stirrups in the columns, and the formwork in the columns without doing any much calculations. So in this project, we have column 1 and column 2. So let's start with column 1. Column type. The column type, we have isolated and attached. The difference between isolated and attached has to do with the formwork arrangement. In some projects, where in attached columns, you have formwork in just 2 sides. While isolated columns, you have formwork in the 4 sides. The meaning of attached is saying that the column is probably attached to a wall. That means they built a wall there already, then the column is just standing between 2 walls. So you don't formwork around it. But I prefer to use an isolated in most cases so that you don't under measure. So if you choose isolated, the formwork that the software will calculate is for the 4 sides of the column. So the next is column dimension length. So this is saying to provide the column length. So here, the column is 230 by 230 and it is 42 numbers. So you provide the length here. If you are doing this, if you are practicing or you are using the software, you can write out this on a sheet of paper. So you just be looking them and be entering the data in the software so that you not be switching between pages. I'm just switching like this so that you can have a view of the data we are entering. So the column dimension length is 0.23. The column dimension breadth is also 0.23. Then the column number is 42, as we have here. We got that from the drawing. 42 numbers. Then the next is number of bars is 4. Then the column bar diameter, that's the reinforcement size, is Y16. It's in mm, so you put it in mm. The next is stirrup diameter is Y10. Then the next is stirrup length. Stirrup length, it's I believe we know what is stirrup length, but this is the stirrup. So you are going to provide just one length. Then the software will calculate the number of stirrup when you provide the spacing. Then it will multiply the total number by the length which you are going to provide. So this is the stirrup length from here to here. This one is indicated as green. So it usually has bend like this or lap. This is called lap. So we have the stirrup lap. And so now we are going to calculate a single length for the stirrup. We'll provide that length here. So we can use the forms at the two bar here at the top of your screen. You see stirrup/links calculator. When you click it, it will open a pop-up window or a form. So here you have an option to select. Say please select. You click please select on this drop down. So we have 3 options here. Regular shaped stirrup is for rectangular and square stirrups or column or beam members. Triangular shaped stirrup is when the member, maybe the column or beam is triangular shape. Then the next is for round shaped stirrup. If the column is round shape, you use this. But we are working on a square column, so we use regular shape. So when you click regular shape, it populates the this is called input boxes. So for example, if I should choose round now, you note that it's requesting for just diameter and concrete cover and lapse. So you don't need any cell or input box that does not have a title at the head. You don't need to input any value there. So we have a regular shape here. It's requesting for the dimension length, the dimension breadth. And here is 0.23. The breadth is also 0.23. Then the next is the concrete cover. And from the specification, the concrete cover for column starter is 50 mm. So in case if you close it, you see it on the windows at the bottom of your screen. So we use 0.05. The next is lapse. Lapse is what I indicated here. This is the lap. So the software requests for 2 laps. So for the 2 laps, it means you add this lap plus this lap. If you are using 100 mm, then you are going to have 0.2. Then if you are using 50 mm, if the length of this first lap is 50 mm, the second one is 50 mm, then you have 0.1 here. If this is 75 mm, you use 0.15 here. That's if you add the 2 laps together. So let's use 0.15. That means we have 75 mm, 75 mm. So when you click calculate, it gives you the length of the stirrup here in this case. So this is the length we are going to use, 0.67 as the length of our stirrup, 0.67. So you can also use this form for other types of stirrup. For example, if the column length is 0.45, you just put 0.45 here. Let's say 0.45 by 0.23. And if the concrete cover specified is 0.5, you leave it at 0.5. If it's 0.25, you leave it at, some case is 0.25. So you leave it at 0.25, then you click this. So it gives you the length of the stirrup. Then if it is round shaped stirrup, you choose round shaped stirrup. You provide the diameter of the member. Let's say 0.3. Then you provide the concrete cover and the lapse. Then you click this. You can decide to use 0.2 as your lapse. It's open. Use whatever you want to use. You just click calculate and you continue. So when you're done, you can close this form. So the next is the stirrup spacing. And from the drawing, the stirrup spacing is given as in foundation is here. This is stirrup spacing, 200 mm center. So you just put 0.2 there. So the next is column in foundation height and starter bar length. So this is what we did earlier on. Remember, we did the computation here. The purple line is the starter bar length. The red line is the column in foundation height. I said the column in foundation height is the height that the software uses to calculate the concrete in the column in foundation for concrete and formwork. Then the starter bar length is what it uses to calculate reinforcement in columns in foundation. So we are going to use the value that we have computed here. Column in foundation height is 0.9. Starter bar is 2.35. Starter bar length. So column in foundation height is 0.9. Then starter bar length is 2.35. So the next is column base. The reason why you need column base here is, you know, when you provide this value, the red line, which is the column in foundation height, I said it uses it for concrete and formwork calculations. Then the purple line is for the starter bar. Then for the stirrups, you know, you have stirrups from the bottom up. The stirrup spans through up. The stirrup starts goes like this. Let's say this is the column. The stirrup starts from here. So you have stirrup spanning all through like this. And the way the software works, when you provide the spacing, it will need a length which it will divide by the spacing to have a number of stirrup. Because when you're doing the calculation manually, to arrive at a quantity for stirrup, the total length divided by spacing plus 1, then times the length of the stirrup. So what we have here is, originally we have provided this length, which is the column in foundation length, or sorry, column in foundation height. Then the next is we also need to provide this so that the software will sum this and this to now have a height that it will divide to arrive at a particular number of stirrup. So that's the purpose of providing this 0.4, which is the column base thickness for BT1. Then the next is adjoining wall thickness. Since we are using isolated columns, so you can put 0 there. The reason of this adjoining wall is, I said earlier on, if it is an attached column, the formwork will not go around the column. It will just be on 2 sides of the column. So you need to provide the width of, the thickness of wall that is being attached to the column, if it is an attached column. So the software will calculate that surface area that is being attached and deduct from the formwork area. So, but since it's an isolated column, we don't need this. But let me just give you a quick check. Assuming we have 0.23 here as the adjoining wall thickness, and in the column type we have attached, you note that the formwork has changed. But if I change this to isolated, see the formwork is now changed. So, but we are using isolated. So let me take this back to 0. So from the data we entered, now we have results or quantities for column, concrete in column, formwork to size of column, reinforcement in column, that's the main bar, in meter, in kg, and in tons. And we also have stirrups. Then we now have this is the value for disposal. You know, in backfilling and disposal. Disposal, I explained yesterday, is the total concrete volume. That's concrete in blinding, column basis, trench, column and foundation, ground beam, and the volume of the block wall is the total volume that will be disposed. So as you are working, the software is calculating disposals for each form: disposals in trench, disposal in column base, disposal in this. You sum them up together, then you now have total surplus disposal. So the next we do is column 2, because in the project we have column 1 and column 2, although they have the same dimensions. But I will just go through it in case where you are working on projects that have different column dimension. You see, we have up to 200 rows here. So even if you have somebody asked yesterday if they can use the software for 25-story building. Yes, in this case, you can use it for even 100 floors. Yeah, because it allows you to provide different types of column 1, column 2, column 3. You just keep on entering them on their individual rows. So the next is the column type. You need to change this to row 2. Then after you change it to row 2, you click on this and you select the option you want. Then after that, you provide the column dimension. Column type 1 and type 2 is the same thing, so I'm just going to repeat what I have there. And the number is 2. Number of bars is 4. So in an instance that column type 2 is 0.45, you just put 0.45. Let's say 0.45, you just put that here. But since we are using 0.23, you use that. The reinforcement is also Y16. The stirrup is Y10. The stirrup length is 0.67. The stirrup spacing is also 0.2. The column and foundation height is also 0.9. The starter bar length is also 2.35. In some cases, if they differ, you just put the correct values there. The base is also 0.4. The adjoining wall is 0. So now we are done with all the columns in this project. So the software will sum the total concrete for column 1 and column 2, sum the formwork, sum the reinforcement. The reinforcement that will be sent to the bill is the one in kg. So it will sum 623.88 plus 29.708 and send it to the bill. It's also going to sum the stirrup. It gives you the stirrup in meter and also in kg and in tons. And this is value to be disposed. So with this now, we are done with the taking off for the substructure for this project. So you see, in a very short time, we could finish up all the substructural elements for this project with column bases and columns in foundation. So now we are going to stage 3. In the presentation we did yesterday, we talked about the stages. Stage 1 is extraction of data. Stage 2 is to input the data in the software and to save each of the page. Stage 3 now is to navigate to result and BOQ. But We have not saved this page. To save the page is same as what we did yesterday. We just click save page. And if you check the file path, which I said is very important, the file path we have here is correct because it's still showing the two folders. So yeah, we are going to save this this page with the same name. The name we have here is regular column details substructure. So we are going to do that, type in regular column details. Then append it with substructure. It's very important to indicate that just use the same title of the page there. So when you finish saving now, I'll show you how to navigate to the results and the BOQ. So we are done with the taking off and BOQ for this project. Okay, it has finished saving now. So I said yesterday that if you want to navigate to the result, the first thing is to take your cursor down. When you take it down, you can see this horizontal scroller. We have two scroller. This first scroller is to move this page around left and right. The second scroller is the one you click and drag to the right end. Then the next thing is to take this vertical scroller. You click and drag it to the top. When you do that, you can see these two small arrows. You can see these two. This is the two arrows I'm talking about. So you can see this arrow. You click on so you click on the one pointing right. You keep clicking it, the one pointing right, till the end. We have a lot of pages. These other pages, they are for round column in substructure. Then the next page is for superstructure. So this is the last page for substructure. This other page are for superstructure. So when we get to superstructure, that's when we are going to use all these other pages. So to navigate to the results, you just keep clicking this button till you get to results. It's very important to click results before you click the elemental BOQ. So when the result page opens, you do have option to choose whether you need Eoq support or not. If you need it, you click provided. If you don't need it, you click not provided. And after that, you click elemental BOQ. So with this, we have all the quantities for the project. For site clearance, topsoil excavation, trench excavation, pit excavation. Remember yesterday we didn't have a value for pit excavation because, like I said, we did not have a column basis in yesterday's project. So this is Eoq support for both trenches and pit, disposal for topsoil, disposal for surplus, leveling and compacting for both trenches and pits. And we also have the anti-termite, backfilling, laterite filling, rock filling. We have damp-proof membrane. Then we have blinding. Then we have concrete in trench footings, concrete in column bases, concrete in ground floor slab, Then we have the column starter as concrete in column in foundation. Then we also have formwork to edges of formwork to sides of column bases, formwork to edges of ground floor slab in meters, formwork to sides of regular column. We don't have formwork in round column because we don't have a round column in this project. Then we have reinforcement. So you have to edit these reinforcement sizes here because the default value that we have here, or default description we have is reinforcement in range. So in this project, we have Y12 for column basis. So you just put what we have there. Then for the column starter, we have Y16. So you edit this to 16. Then the stirrups, we have Y12. So you edit this to, sorry, we have Y10. Then this is for mesh. Then this is block wall and damp-proof course, plastering and painting to the external faces of block wall in our substructure. So with this, we have the BOQ. So the next is to click Save BOQ. So you check the file path is still on the correct folder. So you say day 2 BOQ. So you click Save. So the BOQ is successfully saved now. So if I should open this folder, I can open the day 2 BOQ and make any correction or adjustments that I want to make there. So you can also even decide to just copy the quantities from the bill, because most people already have their format, BOQ format. So you can just use the quantities and paste them in your own BOQ format. Thank you very much for being attentive and for your time. I believe you have learned a lot today, and henceforth you won't be doing taking off manually when you have these kind of projects that we just worked on. So this is the BOQ that we have. So whenever you have this kind of project, you don't need to be doing taking off manually. So once you can extract this data from the drawing, either manually or with Plan Swift, then the next step is just to enter them in EQS2 software. Thank you very much.
Thank you, Stanley. We have some questions here. So I'll start with Alex. He said that we've only examined one scenario of thickness of the column bases. So assuming that the column bases are uniform, but what if they are of different thickness? Okay. How do we, because there is only one space for column bases, so how do we do one that has different sizes?
Okay, let me quickly show you that.
Okay, we are waiting.
So assuming we have different column bases, so you navigate back. If you want to navigate back to your taking off, you click the two arrows, the one pointing back. You click it till you get to the page you want to work on, which is then you can also drag this to the right. Then you click on column bases. Maybe it was not, it didn't follow up from the beginning. I said when I was entering the data that even when you have different column base sizes, let's say base type 1 is 400, base type 2 is 300, base type 3 is 3.5. You can change it here. Remember, row 1 is for base type 1. So you go to the provision for column base thickness for base type 1, which is this. This is the cells that you enter the column base thickness. So let's say base type 1 is 0.3, for example. Then the second row, if you check the second row is for base type 2. So let's say base type 2 is for base type 2 is 0.5, for example. We change it to 0.5. Then let's say base type 3 is 0.4. So now you see the concrete volume will change. So if you make any correction here now, you drag your cursor and go back to the result. You click result and click BOQ. So even if you have 7 or 10 different types of column bases, let's say base type 4 is 0.23, base type 5 is 0.7. So you just keep on changing the values. Then when you make any changes, you must click results before you click the BOQ. So I'm going to click results now and click BOQ. Then you compare the results we have. So this is the first BOQ that we have. You see the basis here in column basis. The concrete is initially we have 24.81 cubic meter. You see now the volume will change. You see the volume has changed because I made some adjustments to the thickness of the column bases. I hope that answers his question.
Yes, I should think so. I can see that some participants are raising their hands. Is it possible to put your question on the Q&A section, please? And I'm sorry, I promised yesterday that I'm going to open the platform for like an hour after the training. I'll do that today. So if there is anything, Stanley will answer from there. But we'll just look through what anyone we can answer live here. So please, the participants that are raising hands, please type in the Q&A section, or later when the platform, the WhatsApp platform is open. Someone wants to know, the Marcus wants to know if she can share the software on 2 laptops. Maybe I think she works. She said she tried to copy from another laptop, from the one she downloaded it to the other one, but it wasn't working. So she wants to know if you can use 2 laptops and transfer it from one to the other.
Actually, you can install it in another computer, but it will not work because the license that you purchase is just for one computer.
Okay. Goodness wants you to review the stirrup length. She's saying that the calculation used seems not to do something that she understands. I don't know.
For stirrup length?
Yes. She said that she thinks the calculation is wrong.
Okay, the stirrup length is wrong. Okay, let's do it practically and see.
Yeah, but then also computing. How about computing different sizes of reinforcement? I think that one can be done just the same way that you spoke about calculating different size of bases.
Yes, ma'am. Yes,
okay, so that's been answered. Okay, I'm listening to you.
Let me first of all respond to the stirrup reinforcement that someone said is wrong. I'm going to share my screen now and we got let me go back to the taking off form that has that. It's a regular column details. I think it's 0.67 that we got then as the length of one stirrup. Just one
Yeah,
stirrup, not.
that's how you got that.
Okay, how the
How
is the
you
soft.
arrive
Okay,
at that 0.67.
we have can you see this calculator form?
As in calculator icon.
Yeah, I want to compute it and okay, sorry, let me share another screen that will show it. Aha, so we have a column that is 0.23. Then if you deduct the concrete cover, which is 0.05, 50 mm as specified, you deduct it in the two ends, not just one end, because the concrete cover is both on the left side and on the right side. So you say minus 0.05 equals to this. That one is just for one end. Then minus 0.05 again. That's for the the left end. So this is the length of the stirrup on just one side of the column. The column has 4 sides. So you say this value times 4. Then you have this. Then you now add lapse. We agreed to use a lapse of 75 mm. That's 0.15 mm. So you say plus 0.15. So that's how we arrived at 0.67. I hope that answers. But I did not do it manually. I used the form here that we have. The stirrup calculator that is on the screen here. So I clicked it, then I selected regular stirrup because regular stirrup is for rectangular and square shaped members. So I typed the length, which is 0.23, the breadth 0.23, the concrete cover. The concrete cover you put here is just for one side, not for the two sides. So it says 0.05. So the software now we multiply this for the two left and right side of the column. Then the two laps is 0.15. So in some cases, some projects they use 0.025. So you see, when I use 0.05, I got this 0.67, which is the same thing as the value we got when we did the calculation manually. But if you are using 0.025, which is 25 mm, then you are going to get 0.87 as your stirrup length. Then the lapse also determines, if you are using 0.2 as the lapse, this will increase. So it's not compulsory that you use what I use. You use what is specified in the project.
Okay. Okay. Petra wants to know if Plan Swift and Microsoft the frame automation in Microsoft, if they can work together with EQS, the software, this training that we are doing, can the software work with Plan Swift or Microsoft?
Actually,
because you recommended Plan Swift for us for automation,
yes,
instead of manual picking of the data.
yes, you can use Plan Swift for extraction of those data, the group A data, which I said earlier. But there's no integration. We don't have any integration yet between Plan Swift and EQS. It's just you can when you measure out those data, you can write them on a sheet of paper, then you enter them on EQS2 software.
Okay. Let me see. Somebody is asking the same question like yesterday, but even myself, I can't remember what you said about BSMM4 formats and EQS.
Okay, I said
Just,
the rule of measurement used is the one that is specified in the SMM4, but we've not done the coding so that in the BOQ as we have here, let me share because the BOQ that the software publishes does not have coding. So this is the BOQ. We have the description, unit, quantity, rate, amount, but we don't have coding here. We are going to work on that, and we will send an update when it is done to everyone.
okay. Is it possible for us to get yesterday and today's recording so that we can play it back and go through what we've learned for these 2 days? Can we get it today or maybe tomorrow so that during the week we can check on
Yes,
it?
we'll talk with Salisu about
Okay.
that. I believe he's currently recording it.
Okay. That's so much we can take this afternoon. It's after 12 already. We don't want to eat into the time that has been given to us. So Stanley, thank you so very much. And every person that have attended today. I hope we've learned something good that will make our work easier and fast. So we'll see you next weekend by God's grace. Please, just like Stanley and Doctor said yesterday, let's practice. Practice, practice, practice. I know that our work takes so much time and all that, but it's all in a bit to make it much better. And we need to practice what we have learned. So thank you, everybody.
Yes.
God bless you. Have a great weekend. We'll see you next week. Bye.
Thank you, ma'am. Bye.
Thank you.
Okay, Salisu. Bye-bye.
Yes, ma'am.